All right, so before we start, let's just have a look at the two loops. So here can you see there's an orange loop and a reddish brown loop. Now the orange loop involves the two EMFs, which is the 20 volts and the 16 volts, and it also involves the three resistors. So you got R3, 20 ohms, and R2. So that's the first loop, the orange loop. And then the larger red-brown root loop is the 20 volts and the 16 volts, and the R3 and the R1. That only involves the two resistors, and the first loop involves the three resistors. So can you see that there are two loops? So therefore, if you were to measure the voltage across R3, R1, that would equal 36. And if you measure the voltages across R3, 20 ohms, and the R2, that would also be 36 volts.
All right, so this is an example. So you got an EMF which is 20 volts, another EMF which is 16 volts, and you've got four resistors. Three of them are unknown, and you know one of them is 20 ohms. You know that the current in one of the one of the currents is zero point 0.5 amps. So the task is to find the resistances of the circuit. Okay, so what do we know? So we can write down that the sum of the EMFs is 20 plus 16. So the sum of EMF is equal to 36 volts. So that is the sum of the EMFs, sum of EMF. Let's write down the voltage here as V3. So we know that this plus this is equal to 36. So V3 plus V1 is equal to 36. If you think about going this path here, because this is a parallel circuit, in a parallel circuit, this voltage across the components here must be equal to the voltage, the sum of the voltages across this and this. So V3, so the voltage across here plus the voltage across here must be equal to this voltage. So that's 20 plus 16. Now we can work out the voltage across here because we can use V equals IR. So using V equals IR for this one, so V is equal to 0.5 times 20. So the voltage across here must be 10 volts. So this is 10 volts across that component. Now here we need to use backwards. So how do we work this out using backwards? So if we say that V, using for this one, V is equal to IR. So that is 6 is equal to, now what's the current here? We know the current is 0.5. So 0.5 times R2. So therefore we know that R2 is equal to 12 ohms. So R2 is equal to 12 ohms. So this one is 12 ohms. Let's just write out 12 ohms. All right, so how do we work out? Okay, so here we know that's I. So the current flowing here is split into two, but then here it comes back again. So here you have I. That is the same as this. Okay, so you know that the power is 30. So using this, we can say that 30, what's the equation for power? So power is equal to I times V. So you know that 30 watts is equal to I times V3. How do we work out I? Alright, so using V equals IR across here, we can say that V3 is equal to I times R3 for this one here, using V equals IR. So V3 is equal to I times R3. Okay, now what do we do next? Alright, yes, because you know that the sum of these two, the voltage across the sum of these two must be equal to VI. So if that is 10 and that is 6, then V1 must be equal to 10 plus 6. So V1 is equal to 10 volts plus 6 volts. So that is equal to 16 volts. So you know that VI is equal to 16 volts. That is 16 volts. How do we work out R1? Alright, so you know that V3 plus V1 is equal to 36, and you know that V1 is 16. So this and this, we know that V3 must be equal to 36 minus 16. So that is equal to 20 volts. So V3 is equal to 20 volts. Then we can work out I. So therefore Verti is equal to I times 20. So therefore I is equal to 30 divided by 20 is 1.5. So it's 1.5 amps. So that is equal to 1.5 amps. That's 1.5 amps. You know that's 0.5. So therefore you know that this is 1 amp. All right, so have you worked out what R1 is? Have you worked out what R3 is? Now we've worked out that R2 is 12. What's R1? R1. So here, using V equals IR, R is equal to V over I. So R is equal to 16. Divide that's 16. The voltage across there is 16. The current there is 1. So R1 is 16. R1 is 16 ohms. What about R3? Now for R3, again we need to use V equals IR here. So V equals IR. R is equal to V3 over I3. So R3 is equal to V3, which is 20, and I3, well, I3 is just I, and we just worked out that I was, what was I? I was 1.5. So R3 is equal to 20 divided by 1.5. So 20 divided by 1.5, and you get 13.3 recurring. So R3 is equal to 13.33 ohms. That says 13.33. The units is ohms. The units is in ohms.